Just give me a second and we'll be going live. So I'm going to share my screen now. There we go. So what you're looking at here is the topology that I'm going to be using today. So this is a topology reflecting an active standby failover scenario for the ASA, Cisco ASA, and this is the ASAv. So just quickly looking here, we have two ASAs. ASA 1 is going to be the active, ASA 2 is going to be the standby. And then we have down at the bottom, we have our inside network here. Ideally, we wouldn't just have one switch connecting single point of failure. However, just for lab purposes, it don't really matter because our main focus is around the ASAs. And same with the top, which is acting as the outside, and we should have actual internet connectivity from this internet cloud here. In the middle, we have failover redundancy, so that if one of the links failed, if one of the failover links failed, we could then obviously use the secondary link. So we're going to configure all that. So I'm just going to pause for a second while I see how many people are actually watching. Let's stop sharing that now for a second. And what I'm going to do, we'll just give it a few more minutes until some more people join, and then I'll continue with the configuration. Okay, so we're going to get started now. Just going to start by sharing my screen, and hopefully you'll be able to see the command line as well. So I'll just fire up the ASAs and we'll connect via console. And I'm just going to change the sharing because it looks as though you can't see what I can see. So just going to share entire screen, and maybe that works out better. Okay, so that's better. Apologies for, hopefully you can see. Just to make it a little bit easier, what I'm going to do probably is make the text larger on each one of these command lines. So if you just give me a second. Okay. We'll just bring this in a little bit. Hopefully that's better, and we'll do the same with the second ASA, just to make it easier for you guys to actually see it. So we'll change that as well. Okay, we're gonna have to keep flicking between the two. Okay, cool. So there's a topology, and we're going to start off by configuring the failover redundancy. Then we'll go on to configuring the or doing the failover configurations, and then we'll move on to we'll do the failover key, so that the traffic, the failover, the stateful failover traffic is encrypted when the two devices fail over. Then we'll configure the secondary ASA configurations. Not much needs to be done there because the information is coming from the first ASA. And then we'll go on to configuring some default routes and additional settings that can help with failover. And I think that is it. We'll see how we get on. So we'll start with this one. So I'll just change the host name just to make it easier. So we'll do host name ASA. We'll call this ASAv1. Okay, and we'll quickly change the second one just so we're not getting confused. Okay. And ASAv2. Okay, so we'll start with ASAv1, as this is going to be the primary. We'll go from there. So first of all, we're going to configure these two interfaces, the active failover link and the standby failover link, and we'll verify the configurations have taken place as well by seeing which interface is actually the active and which one is the standby. Now, normally how it will the interface entered into the redundant logical interface becomes the active interface. However, you can configure that if you want. We're not going to do that. We're just going to put the two interfaces into a logical redundant interface. So we'll do that now. Okay, so we'll do interface redundant 1, and you can have 8, I believe. Yep, so up to 8. So interface redundant 1. And then we're going to add in the two interfaces here. So we've got gigabit 00 and gigabit 01. So we'll add them. So it's member interface. You've got gigabit 00. And what this is saying is it's just giving us some information saying that the following has been cleared on that interface now that we've added it to the logical redundant interface. So we'll do the same then with gigabit 01. There we go. And then if we do show interface, red one, you can see that we have two members, so redundancy information here. So for interface redundant one, you can see that we've got two members, and gigabit 00 is the active member, and gig 01 is standby, as it's not got active near it. Okay, so we'll do a no shut on that, and then we'll exit out of that. And what we'll do now is we shall configure the other interfaces. So if we look at this, so we've got gig 02 outbound, and gig 03 is the inside. So do interface gig 02. We'll just name this one name if outside. Security level's fine. We'll not shut. Interface gig 00. We'll do not shut. 01. No shut. And interface gig 03 is name if inside. Security level 100, that's fine. I'll do a no shut for now. Okay, so we'll do the failover information. So we'll do failover LAN unit primary. So this is basically saying that this ASAv1 is the primary failover unit. And then we'll do failover LAN interface. And we need to give the failover interface a name. So we'll call it failover. And then we need to tell them what interface it is. So our case is redundant one. That just gives us some more information saying that the configuration for this interface has been cleared now. So now that that's been done, we can move on and do the IP addressing for the failover. So we'll do failover interface P. We'll call with the name is failover as we named it, as it's showing there now. And the IP address we shall use is I never gave it an IP. So what we'll do, I'm just looking at the IP addresses that we've got. So inside we've got 192.168.10.0/24. Outside is going to be static using a 172.16, and that's because of the cloud that we're using. So we can use for the failover, just to separate from the other subnets, we'll use 10.0.0.1/24, and our standby IP will be 10.0.0.2. Okay, so that's fine. We'll do interface red no shut, which I don't think it was shut. I think we did that already. So we'll do show interface red one, and we can see that the protocol's up and the line's up. Yep, and we've got both of the interfaces in there that we need. did. Okay, that's the basic failover information done. To encrypt the traffic that's sent across to ASAv2 as it fails over, we've got two options. We can either encrypt with IPsec, or we can use a failover key. So what we'll do is in this instance, we'll just use a failover key. So it's failover key, and we'll call ours Cisco. Nice and simple. Then last but not least, to actually enable failover, we need to do failover. And then we'll write memory. And it looks like I'm having problems saving that, but not to worry. Okay, so we've done that now. What we'll do is we'll switch to the second ASA, and you'll see that not a lot of configurations are needed for this, as soon as we enable failover, the configuration will be replicated across. So you'll see that now. We'll do failover LAN interface, and again we give it a name, so we'll call it failover, and then we're using the redundant one. So we need to actually, in fact, we'll add those interfaces as well. Interface redundancy 1, member interface, and so it's the same interfaces on either side. We'll do a no shut, exit out of that. Then we'll issue the same command again. A failover LAN interface, we'll give it the name failover, and we're using redundancy 1 logical interface for the failover. Okay, so that's just giving us some more information saying that the configurations have been cleared. So now we'll do failover interface IP, failover again, which is the name that we give it. And again, we replicate the same settings, IP addresses we did on ASAv1. So 10.0.0.1 is primary /24. And we did standby as 10.0.0.2. Okay, that's fine. We've already no shut the redundant interface, so we'll go on to failover link failover one, and we need to do the failover key, which we gave Cisco, and we'll enable failover. And once we do this, you'll be able to see the configurations replicate across. So right now it's saying on ASAv1, it's saying that no active mate detected. So if we just do show failover, we can see, where is it? Yeah, this host is primary active. Other host, it's saying it's failed because it's not found it. So this is going to change once I press enter. So we'll do that. And you'll see now that the configurations will start to replicate over. Or this should do anyway. So if I just do show IP brief, I need to interface gig 00. Shut. I need to bring these interfaces up. Okay, that's up, which is fine. And now we can see it's detected an active mate. It's beginning the transfer, same as this one. Configuration replication to mate. So now if we just flip these back over, we'll do a show failover. So we can see that we got the poll time and hold time up there. We can see the difference between versions, so our version and our mate's version. Serial numbers, in our case, are the same. And we can see that this host is secondary standby ready, so it's standby. And we aren't monitoring any interfaces yet, so we're going to do that next. And we can see that the other host is primary active and how long it's been active as well. Inside and outside interfaces, IP addresses are 000 because we've not set them yet. We're going to do that. And then if we go back to the primary unit and have a look at the same, so show failover, we can see that this unit's active, and we can see that it's now got a secondary unit, which is standby, which is the one that we have just configured. So we'll go back to the ASAv v1 where the configurations are done. So we'll do interface gigabit 02 is the outside, if I remember correctly. Show name if. Yeah, okay. So that's right. So IP address is, I need to check this actually before I do that, because this has a pre-configured IP address. So if I just do if config and using 172.16.231 subnet /24. So we'll give this one 172.16.235. Did I say? Yeah, 235.2/24. And we'll do standby is 172.16.235. Move this across 235.3. That's a standby. This information will be replicated across to ASAv v2 as well. Okay, now that's that done, we'll go on to do the internal interface. So interface G03. IP address is 192.168.10./24, and our standby will be 192.168.10.2. Okay. So now if I flick back to ASAv 2, and we do is we can see that the IP addresses have been populated, and by default, the interfaces are monitored. However, we can also monitor the explicitly monitor, if you like. So this is saying that our interfaces inside outside. So it's configured our interface with 235.3. And the primary that we configured is 235.2 for the outside, and likewise inside is 10.1, and the outside, the inside of the secondary is 10.2. So it's replicated that information across to the second ASA straight away, which is good. So what we'll do is we'll configure the default route. So we'll do route outside and the gateway 172.16.235.1. Let me just try and ping Google because we should have internet access, and yes we do, which is good. So that's good. And then what else do we need to do? We can actually change the prompt so that we know which device is primary or active and which device is secondary. So to do that, we just do prompt, hostname, state, priority, and that's it. As you can see now, the prompt has changed to ASAv1, and it's telling us that it's the primary. We'll do the same for the second. In fact, the secondary is done. Sorry, my bad. Yep, it does it for the secondary as well. So that's actually telling us that this is standby secondary and active primary. Okay, so we need to now, I've got my Windows 7 lab machine here. So what we can do is we'll test some failovers. But before we do that, we shall monitor the inside interface. And outside's already monitored. However, we'll just do that. And we should do show monitor interface. So now we can see that the interfaces are monitored for failover. Now we'll jump onto, before we do that, in fact, I need to create a NAT rule for inside to outside. So we'll do network object, sorry. Oops, come on now. There we go. Object network. Don't know what I'm doing there wrong. And we'll call this one NAT. In fact, no, we won't. Let's do no network object, and we'll do inside, and we'll do subnet 192.168.10.0/24. Then we'll do NAT. We're going to do NAT inside to outside, and it's dynamic, and it's using the interface. So this command here, this address is mapped to IP. So we're using PAT essentially, port address translation. So that's that done. Look over to our lab machine. The IP address is already configured here for .3 within the subnet, I believe. So let's just, can we edit this and make it bigger? Font. Can we make it bigger? Okay, that didn't work. Option. Tell you what, make that big like that. And then it's not letting us make it. Does that work? That's a little bit better, I suppose. So hopefully you can see that. What we're just going to do is we're going to try enable a ping to Google's DNS server continuously, and it's going to fail. And the reason why it fails is we've set up NAT. There's nothing wrong with NAT. So if we do, we'll exit out of that. We'll do show NAT, and we can see that we've got translated hits and 3 untranslated hits. So if we do show xlate, you can see that we've got hits from our lab machine in the background there of 10.3, and it's going outbound. And we can see that it's PAT, TCP PAT, UDP PAT. So the reason it's failing is because we aren't inspecting ICMP on the ASA. So we'll do that now. So we need to do policy map, global policy. And then we'll do class inspection default. And then we'll do inspect ICMP. And once we press enter, just before I do that, once we press enter, we'll see that we start getting replies. So I'll just give it a second, and there we go. So we're getting replies now, which is good. So now that we've done that, IP addressing is done, default routes done. We'll just test internet connectivity here. We'll just try and open a web browser. And we'll type in something like, I don't know, CNN.com. And it takes a little bit of a time because I'm using a lab machine. But as you can see, it's loading up now. And if we do a short xlate, we can see that we've got all the nice translations happening. There we go. So that's the configuration done. What we're going to do now is we are going to, let me just have a look at the topology. We're going to simulate the failover. So we can do that by doing this. We could do set the second ASA to become the active by doing failover active. And just before I do that, I'll show you that. Where is it? Failover. Ah, there it is. So make this system, let me just drag that across a little bit, make this system to be the active unit for failover. So we'll do that now, and we'll see how quickly the failover occurs in terms of the pings on the left-hand side. So failover active. Into active now. Yeah, one timeout, and we're back on. So now if this is ASAv2, so we'll do show failover. And we can see that this is a secondary unit and it's active, and the other body, the primary is actually on standby now. So what we'll do is we'll switch this one back to active, failover active. So that should switch it back to active. And we can see now that it's gone back to active, which is how we want it. Okay, so CNN is still taking a long time to load, but then if we look milliseconds for the responses, and see that it's not the best. So let's just, while we're doing that, we'll just load Google. Oh, now it wants to load. But we're going on Google. Yeah. So now we need to delete the failover. So as we did, and we can see that is the interface. We can, once it's in a redundant, logical redundant interface, we cannot shut down the interface. As we can see there, you must disable failover first to execute, which makes sense. So we need to try and pull. Let's see if we can delete that. Yeah, it's not going to let me pause running, so I don't think we can actually simulate redundancy on the actual failover links. But what we can do, let me just get lab machine back up, and we'll see if we can change the priority of the interface. Member interface gig 00. Is it? In fact, I don't think we'll do that. I think to save time, what we'll do is I'll reload this device, and judging by me trying to copy the configurations and I'm getting an output error, it's not going to recover the configurations while I reboot it. But just to finish off this video, what I'll do is I'll reboot to simulate a device failure, that being the first ASA, this one. I'll actually reload the device, and then we should see the failover come over to the second ASA. And because once the first ASA is reloaded, the configs aren't going to be there, the second ASA will be active role. So we'll just get our virtual machine up, and what we'll do now is we'll reload the first ASA, which is active at the moment. We'll press save, but it's not going to let us do it. And now you can see it's shutting down the machine, and we've got timeout there, timeout, timeout, and we've just seen the second ASA switch to active. So we've got 3 timeouts, and then it's back up and running. So we've seen that the failover has occurred. So if we do show failover, we can see that the secondary unit is now active, and we can see that the primary has failed. So we can run a few other commands, show failover history. We can see that all the failovers that have happened and why. So hello's not heard from mate. And if we go back to the first ASA, it's just finishing booting up. What you'll see now is obviously the commands out there. The configuration is not there, sorry. We can see that failover's off. So in situations like this, where actual devices fail, real devices fail, we can see that we can maintain with the ASAv by configuring either active pairs or active standby pairs. Simply, by doing this, we can save from a lot of headache in terms of network outages, etc. Then we can replace the primary device if required, and reconfigure that, then bring that back up online, and everything, it'd all happen seamlessly. So that's pretty much it in terms of this lab and what I wanted to show you. I hope you've enjoyed it and learned something from this. This is one of my first live videos, so thanks for those that have took note and come watch that, and that's good. You know, I look at doing some more live videos. So yeah, thanks for watching, and that's all from me. Goodbye.